Hey there, I'm Rich Green, SANS author and instructor, and I want to give you a quick glimpse of just one of the 90+ hands-on labs you'd encounter in SEC275. This course covers a huge range of skills, but I thought we'd have a little fun and run through one realistic, high-impact lab right now. So, most privilege escalation demos go straight to root. Today, we'll do something more practical and we'll become a real user who actually has misconfigured access that we want. So let's go. First, let's try to access this user's directory. We'll use the cd command to make that happen, or to at least try. So cd user, oh, I'm already getting it wrong, home, power user. Bam. As you can see, permission denied. That's our challenge, right? We want files or access to or something within home power user, but we can't get in as is. So we are going to search the system for SUID binaries or SUID binaries. These executables can run with someone else's privileges. We use the find command to make this happen. Now there are plenty of misconfigurations you could search for on any given system, which is why I always preach about how important permissions or authorizations are at a fundamental level. So let's run that command and see what we can find. Again, we'll use the find command. We're going to start at the root directory, looking for certain permissions, particularly the SUID one. And we're going to get rid of all of the errors out because we don't need to see any of those, right? So we're going to run that command. It's going to take just a little bit to come back. And there we go. Take a look at the results. Utilities like passwd and SU are expected. Now, one entry stands out, user bin cache. That's unusual and worth investigating because I can't say in all my years I've seen it before. So let's inspect the binary to confirm ownership and that SUID bit. We can simply run the ls command on this to look for that. Let's do just that. We're going to add a couple of flags or operators here. ALH, the TAC A is looking for all hidden files. The L is for long listing format, and the H is for human readable. User bin cache is the binary that we are looking for. Now, notice the permission bits, RWS. That S is the set UID bit, and the owner's power user. Executing this can give the process the effective identity of power user, exactly the vector that we want for this. It's awesome. So let's continue. We can look at running strings to really look at a particular binary to see what that's going to look like. And to run that, all we simply have to do is just use the strings command. So let's run the strings command. Strings, we want to run user bin cache. All right, I'm going to pipe that in the head just because I don't want a lot of output. I don't want too much output, right, for this particular item. So we kind of run through there, and you could run through a lot more if you wanted to look for those, right? Those strings, if you were to look through all of them, look like a shell. This is essentially a copy of shell owned by power user. Now, a shell with SUID owned by a non-system account is a serious misconfiguration. Let's execute it, preserving elevated effective user ID to get a shell as power user. But before we do that, let's take a look at who we are right now. To be able to see who you are right now, you simply use the ID command. The ID command shows you your UID, it shows you your group ID, and any groups that you belong to. All right? This is just good for us to know, because I want to show you something a little bit later on. So, let's continue with the process. As I told you, we are going to run this command utilizing the effective permissions of the owner of that file. So, user bin cache, and we're going to throw that TAC P on there to make that happen. Oh, well, check that out. We got a different shell. Now, let's check our ID again, well, with the ID command. Look closely. Our UID remains the same as before, right? But the EUID, or the effective user ID, is power user. The kernel uses effective UID for permission checks. We've become power user for file access without becoming root. We can prove it by changing into the power user home directory and creating a file, which is what we tried to do at the very beginning of this entire lab. So how would we do that? Well, we're simply going to cd home. Can't be using tab completion in this particular shell. Home, power user. Oh, you'll notice we didn't get an error. Okay, well, let's try to create a file. We're going to touch test.txt. We didn't get an error again. Let's try the ls command. Oh, you'll notice test.txt is in there. Because of our effective identity, right, as power user, these commands succeeded. We can now read, write, and modify files owned by that user. Again, exactly what an attacker wants if they're after that user's data or trying to laterally move throughout a system or whatever the case may be. So, 3 things to take away from this one. 1, the S bit on a shell is extremely dangerous. 2, attackers often target real users because user accounts sometimes hold the juicy data. Yes, I would love to get root access, but sometimes it's a tad more difficult, requires a little bit more, zest, right? And more folks watching for that. 3, detection is possible. Regularly scan for SUIDs, audited executables, and use file integrity monitoring. Some mitigations you can implement. Remove the SUID bit when it's not needed. That would be a pretty good start. Investigate ownership and provenance, and add auditing rules to watch SUID executions. If you're unsure, restrict access until you confirm legitimacy. Hey, if that pulse quickened a little bit, this is something brand new you've never seen before. Imagine, again, 90+ labs like this. Hands-on, practical, and instructor-guided, assisting you on your entire journey. So come join us in SEC275 and build the muscle memory to both find and fix issues just like this. Enjoy.